Alright then. So now, we are coming to a circuit. Basically, the circuit we looked in the last video, except for we're using a light-dependent resistor instead of a photodiode. Now, last video, I accidentally, when I was building the circuit, forgot to put the 100K resistor. I think I had 10K there, scribbled it out, 100K right there. And that circuit still worked out just fine. I noticed while I was making the video that this resistor was not there. So that's 100,000 ohm. Of course, you need the 100,000 ohm resistor for this circuit. I'm going to make it as dark as I can. Doesn't matter. This is a resistive element, that light-dependent resistor. And so its resistance goes up or down. But either way, no matter how dark you're going to get it, you know, maybe like if it's pitch black, not a single amount of light at all, maybe it would work. But any case, we have it there. You can see we got the red LED when it gets dark enough. Also, I got this pack. It's sliding into view. I'm using a 180 ohm resistor instead of 220 because I don't know where I set my pack of 220s. And I mentioned in the last video that, you know, this is a simple topic. I'll ramble on a little bit more. I, you know, put them back in there. Maybe I stuck it in the wrong spot or something, but I flipped through them. I didn't see 220, so I don't know where I could have set them. I had a bunch of packs out in a recent video, and stuck them in there, and now I can't find 220. But in case, 180 will work just fine. We don't even have 5 volts across the red LED and the 220 when it gets dark enough. Now, the lamp is at its brightest setting, and so the lamp's probably like flickering a little. It's got multiple lights. Some of them may be flickering, so maybe that's what it is. We're right on the edge of that flickering. But if I dim the lamp, now I can you know, cover it with my finger there, and we'll get it slid over. Let's see if I can kind of get a middle ground region. I don't seem to be able to, but yeah, you can see, you know, we kind of have, yeah, we're getting a little, if you're really talented, you might be able to get a flashing effect like that back and forth. I don't know how well that's showing up. Let's see if I can do that again. Again, this is kind of a simple topic, so I'll play around a little bit more. But yeah, you'd have to really know how to wire this up to get that effect, to keep going like that long period, you know. That's just kind of a thing I stumbled on right there. Get the light level just perfect, up and down. But any case, we have the 555 wired so that the output will be held high, even though it's low right now. We'll talk about that coming up. But we ignored this right here, the reset pin. Pin 2 is directly to ground. That's telling the output to go high. That's what it's always telling it to. Pin 6 is the weaker pin anyways, but we want to keep a low voltage there, telling it not to do anything. So low voltage to pin 2, it says output goes high. Pin 6, it tells it not to do anything. It's waiting for a high enough voltage. Now, pin 2 will overpower pin 6 anyways, but we have pin 4 here. That overpowers pin 2. It's the most powerful input right there. If you tell the 555 timer to reset, that means set it low, it's going to do so. And if it's already low, you know, just stay low. But if it's high, then it will force it low if you tell it to reset, no matter what else everything wants to do. So pin 2 is saying stay high, but when pin 4 says go low, then it goes low. So that's what we have with enough light. You can see we got low enough voltage. I think you need 0.5 volts or less from earlier testing. And so if this is a resistive element, it's going to pull at 0 volts if you get rid of this resistor, no matter what the light level is. But when it comes to this resistor, this is a pull-up resistor. So I wrote 100K on there. Yeah, that definitely, it's easier to see on camera than in person, I think. But that I accidentally wrote 10K there. 100K. 10K, you would really need it bright, I'm guessing. Because the lower value resistor you get here, the more it's going to pull that voltage up. And so the harder you're going to have to pull it down, which means less resistance right there. In this case, that means brighter light. So you can adjust the sensitivity here. But 100K is working out really well, as we see here. We got 5 volts pulling it up. So yeah, that's what it is. Ultimately, without pin 4, this circuit wants to keep the output high because we got 2 to ground right there. I just used a little jumper coming up there. That's another thing. You don't have to, everything that connects directly to a supply voltage, we could put a resistor there too, doesn't matter. Again, even high value resistors will let the voltage through as long as it doesn't demand any current. And that's what we have here. It doesn't demand current. It's just going to an input that looks at voltage. So yeah, you can, if you have multiple pins going to the same supply voltage, you can put one of them to the supply voltage and then just have jumpers connecting the rest of them to that pin. Doesn't matter, it's all direct to the supply voltage. So I thought I would mention that really quick. I didn't really talk about that in the last video. But yeah, we have to get it dark enough again. So lamp is at the lowest setting. If I put it at the brightest setting, it's harder for my finger to do it. But ultimately, it should be the light going off right there. And as I mentioned before, if you forgot by now or something, weren't paying attention, that's not red, black for 220 and then black again. It's can't remember what 8 is, but that's the color code there. And so I used a 180 because I can't find my 220s. So yeah, I mentioned pin 6 when it's ground, that's disabled, tells it not to do anything. So yeah, I pretty much covered everything. Of course, you got to power the integrated circuit. A lot of integrated circuits symbols don't even show the supply voltage. Usually the 555 timer does. But if you're using a 555 and it isn't, look at the other voltage being applied to the circuitry, and you know that has to be powering the 555 as well. The 555 could be using different voltage than the circuitry, especially the load. But you really got to know what you're doing. It's not really intended for that. So yeah, positive supply to 8, and then the negative supply to 1, which again, we're putting 2 directly, trigger pin, directly to the negative supply. So we can just share the one that is supplying the negative power to the integrated circuit. We could just use another jumper to go across if we want to, but I only got so many of these gray ones, so I tried to not use more than I have to, especially you can see I already got 3 on the board. We could use another little jumper. I have one that jumps across over the component. We could have tied ground, actually I would tie it to pin 2 there, and it would also be connected to ground through there. That's how ways you can adjust it. And by the way, up here is the photodiode I used in the last video. And so you use it reverse bias. It doesn't matter which direction you put this light dependent resistor. And interesting thing is they kind of look like their schematic symbol. You can see the swiggle lines. I think that's the resistive element based on how much light is falling on it. And so some of them are different color, and they're either not as closely spaced. Some are wider, some are thinner and stuff. Ultimately, the amount of light falling on them determines their resistance, but the ones that look different will have like a little bit different resistance at a certain light level. So be aware of that. If you need 2 that are exactly the same, you got to make sure they look exactly the same. But yeah, we got the photodiode. Again, I did this in the last video. Used it reverse bias. And this one, I already demonstrated at the beginning with the resistor. You need this pull-up resistor to overcome the pull-down resistor. Pull-down resistor will always pull it down if you don't have a pull-up resistor. But with the pull-up resistor, I'll get it dark again. There you can see it worked. If I yank this now, so this is where it wants to be, reset anyways, but we make it dark, it doesn't, and now we got the high output. So I don't even think we need that resistor for the light, or the photodiode, but we definitely do for the light dependent resistor. And I'm going to end the circuit putting that back into place. Yeah, since I'm putting this one in by itself first, there you can see, no matter how dark, probably I get it. Okay, there is a point where it will get dark enough. So it'd have to be a lot darker than what we got now. And that was pretty dark though. But in any case, to set the sensitivity, use a pull-up resistor, no matter what. Even if it kind of looks like with the light-dependent resistor, you don't need one. You probably do, even though I was getting a better effect than I thought I even would. But yeah, rambled on long enough. Hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.